Hello and welcome back to Make HTML5 Games. I'm Dr. Abstract, and in this one we're going to look at a physics game, and don't worry, we'll make it easy for you. Yay! Let's go look at the Zim site now at zimjs.com, and we can find a bunch of tutorials, other tutorials as well. If you scroll on down here under the games, right here, it's also in the Learn section. But right at the top of the games is Making HTML5 Games the Easy Way. And we had 4 of them before, and this will be our 5th one. So if we come on in here, here is what we're making, this game right here, where we try and free the little pink circle from the walls. Oh, using this ball right here, and we have to reflect it off. Okay. There's also a more advanced one with scores and timers and sounds, and that's available right here. But we're going through the tutorial for this one, which is pretty well a complete game as well. Shall we have a look at it? So this will go to the Zim Zap demo page here, or promo page, and we can hit the full like that, or we could go see it in the editor. So here's the game. If we pull on that, you'll see that it bounces. Oh, and there, it just bounced off the wall. And we have taken away some of the blocks that we need. But if we don't reflect it off the wall, it gives a little, that reflected off the bottom wall. It gives a little white one. Oh, and another white one. And we can't break those anymore. That's it. That's our last chance. So the trick is, it's not just this wall. Oh, it has to be the purple wall that it bounces off. So this purple wall kind of moves around, and we always have to make sure that we bounce it off the purple wall to be able to get to our inner core there. Okay, and so that's the game. There's no sound, there's no score really, but when it finishes, when we get to the pink circle, it will have a pane will pop up saying, "You've won, yay!" All right, so let's see that again. If we refresh, there's instructions here, free pink circle by bouncing black circle off reflection wall. And as soon as we pick up the circle, those instructions go away. And I bounced off the wrong wall. All right, let's see how we can make this game then. We're also creating a textual text and pictures tutorial right here on Medium. And we are currently now making this video right here. So there's a big long preparation, and if you want to follow all the instructions that we're doing here, that's available on Medium as well. All that stuff is just getting you started. We're going to getting started here too, and then we get into the game and how to build the different parts. So we'll be doing some of that. Maybe we'll see how it goes. I don't know if you can stick with us. It might take an hour or two. But we're going to start with just some overall physics stuff to talk about how we can make this circle move in various ways. And then we'll get in and we'll dig into the code for this game. All right, let's see. What do we want to do now? So you found that okay? That was right in here. This code is also available in the editor. So if we are here, there's the tutorials on Medium, and we'll add that tutorial as well. The videos on YouTube, the complete, simple, okay, so these are the examples in the editor. So if I press on that, once again, it opened up here. Last time we just hit full, but if we hit the editor, or indeed hit the picture there, now this is showing up in the editor. And when it's in the Zim editor, we can hit code like that. And then we can copy the code. I'll overwrite my code, I guess. I think it's probably the same code. We can copy the code over to this side, and then we can test. So now we could make changes if we wanted to. For instance, if we have a pink circle there, we could take a red circle there. And I hit save or hit test again. And now the circle is red. So this is the Zim editor where you can edit things on the side or even create your own. We call them zaps right there. And the zaps has a list of things. If we search for physics, for instance, physics, There's 33 results there. So you might want to do that. There's a claw with physics and buoyancy and dominoes and kicking and ring games. Okay, and all those are the same where you go in and you check them out and you can copy the code over and play with the code. Okay, so we'll leave this for now. We're not going to do our tutorial in the editor, but if you want to follow in the editor, you can. If you don't want to get VS Code, so VS Code is a nice, easy desktop editor, so to speak. I'm looking at it right here in the background, and that's where we're going to be doing our coding. And if you want, back in the tutorial here, it talks about how you can get VS Code. There's the link to it and stuff like that, so you can read about that. To get VS Code, we're going to grab the template, so we're going to follow these instructions to grab the template. But if you want, you can code all of this in the editor, and here's some information about the editor versus the VS Code. And when we're making the game, we're going to be doing that kind of stuff in our editor. But if you were in VS Code in the if you were in the Zim editor, then you would have to add that. So in the VS Code, we add this. In the Zim editor, we add that. But basically, after that, it's all the same. So that will be up to you. And let us proceed then with that kind of stuff. Out on the Zim site, we're going to grab our template. So if we are on the Zim site here, so here's Zim, zimjs.com. And we are looking for our code template. So we hit the code, and there's the template that we'll be using. We hit copy button like that. We come back into VS Code, and I've made a new file called physics.html, and then I paste. So VS Code is free from Microsoft. It's really quick to download and install. It doesn't take up it doesn't take up too much space or time. It's the industry standard now for coding, and it's just wonderful. So you should probably do that. Go get VS Code. We've also installed a couple extensions here, these little blocks. One is called, the ones that you want anyway, are Live Server right there. If you're working with images, Live Server is the easiest way. It avoids Canvas permissions for looking at local images. So Live Server's an easy way. I also like Open in Browser. Do you see it anywhere? LMNOP. Yeah, there it is. Open in Browser right next to Live Server. Okay, so those two, just do a little search for them. Live Server, Open in Browser, and that allows me to right-click and say Open with Live Server or Open in Default Browser. So I just hit Open in Default Browser, and this is what my template looks like. Okay, that's the physics page in my tutorials that I'm doing. So that's what the template looks like. It's a purple circle that I can drag around. And let's go see what's in that template. So we can close that by doing that, and we can see our file system here by doing that. And I have a physics file that I'm working in. Or you can drag the edge of that out as well. So here's my template now, and we can put physics game in there. That's just the title in the browser. We are bringing in Zim, but if we want physics, we'll need to bring in physics as well. So that's importing Zim Physics, which imports this thing called Box2D, which is a physics engine, as well as the Zim Physics Helper module that makes Box2D much, 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 much easier, like 1/10 the code. So you'll see that Box2D is actually quite complicated, but Zim makes it easy. So we're in a frame, and that is what sets up this light gray box here. That light gray box is called the stage, and it's keeping the aspect ratio of 1024 by 768 and fitting it into the browser window. There are other ways to do it as well, a full mode and so forth, but this will be fine for physics. And we actually want to change this up. We'll leave it like this for now while we experiment, but for our game, we're going to make it square. And that just means we put the same width and height. We're also going to make it have a black outer color, and we'll make it white on the stage color. But for now, we've got that circle there. Let's make our circle just a little bit smaller, like 50, and we can keep it purple. We'll center it, but we're not going to put a drag on it. So this is Zim code right here saying make a new circle, 50 in radius, purple, center it, and drag it. And as you can see here, if I refresh now, it's a little bit smaller, and indeed I can drag it. But we want physics. We want to be able to throw this around and have it drop to the ground in a sense. And so for that, we ask for physics here. Const physics is equal to a new physics. So to get this to work, you would have to make sure that you add on the physics there. And now we'll have physics available. By default, the gravity is 10. We can set it to 0, but let's leave it at the default for now. We've got a circle there. We're no longer going to drag it. Instead, we will say dot add physics. And are you ready? Bum, bum, bum. We come on over here, and our circle just drops to the ground. I can't throw it around again. It's also not very bouncy, is it? All right, so if we want to throw it around, if we want to throw around everything, we can just say drag, and from now on, anything that we put in there that is dynamic will be draggable. We have two settings here. The very first setting here in add physics, if we say false, that means it's not dynamic. That means it'll be static and we can't move it. But if we leave it the default, we'll now be able to drag this thing around. So let's try her out. There it is, and we can throw it, but it is really not at all very bouncy. But we can increase the bounciness, so that is right in here. It's a parameter that's available for us later, so we would have to go null, 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 and finally get to bounciness. But Zim has Zim Duo, which allows us to put in bounciness, :1 is really, really bouncy, 0.5 is probably going to definitely be bouncy enough for us. And there it is, and now it's bouncing off the walls as we kind of expect, and that's probably fine. The other thing that affects it is its damping. So that would be its linear damping and its angular damping. So linear, which is what we're interested in, we won't even notice the angular damping because of the circle as it rotates. That's how easily it rotates. But we can't even see it rotating unless we put something inside. And actually, it is always rotating, but since it's a circle, we can't really tell. Linear, :0.5 as well. And now we'll see that we might not be able to tell too much here when we have gravity set, but as soon as we go to more of a top view, as a matter of fact, let's do that now. So we'll say, hey, no gravity, please. And this becomes more like a top view, kind of like air hockey, where you pick it up and can throw it around like that, and it bounces off walls. So there is friction as well, but friction is not happening here. So friction happens when one physics object is on another. In this case, this physics object right here, the background isn't a physics object, so we can't use friction like this. That friction would help if you had a rectangle slide with gravity sliding along a ramp or something like that. Then you can set the friction to 0 and it will just slide like it's ice. But here, it's the linear damping that is adjusting things. So if we set linear damping of 0, then that means there's no damping and it just kind of keeps on going. Okay, which we don't want that. And if we have a linear damping of 1 here, then it's hardly going to move at all. Well, I guess we have to put in more, so what about 50? Can we linear damp it to 50? Yeah, now it doesn't slide. I can hardly even pull it, but it's still a physics object that moves around, which could be handy. Anyway, you get the idea. So we'll keep it at something like 0.2, And the bounciness at 0.5. Great. So that's when we pick up the circle and throw it around. There may be other things that we want to do as well, and just to, what we usually would do if we're introducing physics is create something that's more static. So let's make a new rectangle, and we can make it, say, 100. Well, this is the width, 200 comma by 30, and we'll just leave it at black. We'll dot pose this, and well, let's rotate it as well. Dot rot so that we can see what that does. 30, 20, 30, whatever, and we'll pose it at 0 comma 100 up from the bottom. So that's from the 0 from the center and 100 from the bottom. So with physics, you create it in Zim first, and then position it, rotate it how you want, and then we add physics. Now this is going to break, add physics. Maybe I'll show it to you broken. First thing is, if we don't want it to move, we would say false here, but it still will be broken, and we'll kind of see why. Do you see that? I'm throwing the ball off there, and it didn't even hit it there, but it hit it up there. What's going on here? The issue is any physics objects need to have their registration point in the center, .reg in the center. And so basically it was assuming the registration point was in the center, which a rectangle doesn't have it. Now if I throw this is kind of silly because I don't really want to throw it at a ramp. So hang on. Let's change that back again, back to having a ramp or having gravity, and there it is falling down the ramp. Okay, and if it's bouncy, it kind of bounces along it, but there it is rolling around it. So there we have a static or a dynamic false object in there. If it weren't false, then we can move it around because we said drag everything. And now it falls, and we can pick it up, pick this one up, and we can balance things. Whoa, there we go, balance. And anyway, so you can already see that there's some games that we could start doing, like a keep it up game or something. Use this to kind of keep up your ball. And if it hits the ground, we can tell we have contact to tell if it hits the ground. So we're already into making kind of cool games. You could, if you make a little basket up here, you could sort of hold it up there and try and get the ball in the basket. But sometimes picking up the ball and throwing it isn't our favorite way of shooting things. We want more of like a pool shooting kind of feel. So let's try that. We'll go back to the top view as well with 0. And we're just doing kind of a quick intro to physics before we dig into that game. We've done intros to physics before in videos as well, so I don't want to spend too much time and look at everything because there's all sorts of things to do with physics. There's how to join things together, there's forces, there's etc. But we probably should see a force here. Let's do it a different way though. Rather than typing it out, we've made a really cool, very simple demo page right here called physics, and it's in HTML5, and we'll put the link into that into the video as well underneath there. And so what this is it's a bunch of different examples of controls. So why don't we just look at those? As a matter of fact, probably be easiest just to open it up here. So I'm going to open it up in a default browser, and in this case we had a red ball that we were throwing around. Okay, and that's basically what we had already had done there. But now what we're going to do is leave the physics with no gravity, and we're going to comment out this part right here, so we don't even have the physics drag. And by the way, the drag, you could specify drag circle, and it would only drag the circle, or drag bar, or whatever we call it, the bar, and it would only drag that. Or you could pass in an array of certain ones to drag. But if you just say drag with nothing, it drags everything. All right, so the next one we want to try is a proximity shoot. And so what that is, it's quite cool. So I'm uncommenting that. We'll look at it in a sec. Let's see what it does over here. So it's made the ball, but it's put this little border around it. And what I can do is press anywhere within this border, And the closer I press towards the middle, the slower it goes. And the farther I press, the faster it goes. So now I can kind of press it slowly by going to the middle and pushing it about, or I can press it faster, and it just depends on what force you put in there. But you can also see that it's rotating. You see how the border is spinning as well. So that's been rotating all along. We just couldn't really tell. So what do? We declare it a force, and if we set a force of 20, then we're going to get something that obviously is different there, wouldn't you say? Pshroom, pshroom. And if we made it bouncier or decreased the linear velocity, that could go for a long time, but that's a stronger force. And we'll leave it at 2. We have our circle. We've added physics in the same way before, but here we've made a ring that is bigger. It has a bigger radius than our circle, and it has a faint color. That's so that you can interact with it. If it didn't have a faint color, we could do another thing called expand, but expand works on a rectangle, so then you'd kind of be stuck because you could press here on the border or the boundaries. But anyway, this is fine. It's a little faint. That's an alpha of 0.01 is the faintest that's interactive. And then a tin border of 1 and true for dashed. Okay, so you don't have to do that. You could have just made it something like light. Well, I can't remember what color is lighter. Maybe get rid of all this stuff. And then it looks like this. Oh, it's on top. So we certainly don't want the ring to be on top at that point, so we could center it on the circle at level 0, or we could say dot bot after and it goes to the bottom. And now we've got this kind of situation where, or you could use the alpha of that, so lighter, I may as well just say white at this point, white dot 2 alpha, 0.1. And now we've got a light sort of background there. Well, that's a little bit too light, maybe 0.2. And that's also a nice look as well, where that's, or you could make that show up as you roll over the ball, then this area shows up. You could do that with a HUV. So all these kinds of things are possible like that. But isn't that, I find that that's quite a nice way to shoot things about like that. And let's go take a look at the next one. I'll undo that and just keep the little border around. I think that's good. So we'll comment this guy out, and let's go to the slingshot. And the slingshot is what we're going to use for our game. And it looks like that. So it's more code, but it's not that complicated. Let's have a look at how this slingshot works. So the slingshot, you pull back and a little line is drawn from wherever it was to wherever you pulled back to. And it's pretty good too. You can set it up like the Angry Birds, where this is working with gravity. When it's working with gravity, it's a little bit different. And we did these code in 5 minutes videos, went through how to make Angry Birds basically. It took us more than just one code in 5 minutes. I think it took us 4 or 5. But hey, that's 20 minutes. That's not bad. So there we made things to knock over. But the trick is, if it's gravity, you don't want it to fall. So that means you got to actually start the ball off with your physics with dynamic false. And then when you mouse down, okay, well, let's put it in place since I see that it's in here anyway. We'll have the gravity here. If we refresh here, you'll see that it falls, at which point it's not as easy to do the slingshot anymore because it just fell to the ground. You're kind of going, ah. So how you would start that is you would set it to be dynamic false like that. And as soon as you mouse down, then set the dynamic to true. And what that looks like is as follows. So now it hangs out there, but as I pick it up, then it's ready to go. At which point you can find out when this stops moving and put it back again. And that's sort of the Angry Birds technique, where you always sort of get it back again. And otherwise it's hard to kind of, you have to catch it and slingshot it. Anyway, there you go. You have that in there. So it's hard to say if I should go over all of the slingshot stuff. Maybe just quickly. Physics is pretty well the same as before. We are going to put this back to 0 because that's what we've got in our game. And basically, as we mouse down, we add the line. So the line looks like this. We add the line, set its length to 0. Here's the start X. And then we add this ticker right here. A ticker just constantly keeps going. And we're constantly making the line go from wherever the circle started to wherever the circle is. When we press up on it, we remove that ticker, so it no longer tries to do that. We remove the line, and we create an impulse force. An impulse force is a one-time force that is basically however far we've pulled that elastic times whatever force we want. And again, in the Y, times whatever force. So pretty straightforward. Our circle gets an impulse one-time force, the distance in the X times the force, the distance in the Y times the force, or the difference in the X and difference in the Y. All right, so there we go. It looks like there's more stuff here, but it's not that complicated really. All right, let's comment that out and carry on. So that's the one that we're going to use. There's also other techniques. You can use arrows. What are arrows? Oh, right. So that would be something like we put the circle on there, we add physics, and we use control, and the arrows are just our keyboard arrows. So here we are. Now I use the keyboard arrows. So I'm using the keyboard to move this thing around like that. If you're on mobile, though, you don't have keyboards, so you can use a D-pad. So there's the D-pad that will do that. And you want to see the D-pad or not? I think you can imagine what it looks like. Doesn't take too much to do. Oops, and the D-pad itself there. So a D-pad's a little round thing there, and you can sort of put your thumb on it on mobile and move back and forth, and that's the D-pad. So I'm kind of moving that around with the D-pad. And you can also use a motion controller, and anyway, there's a variety of different ones. So on here, next we're going to show the targets, so we should probably keep something in here. How about our little slingshot, I guess. Guess I'll use the slingshot. And sorry. So we're bringing back the slingshot, and now we've got different types of targets. So this is a net that you might want to score on. Oh, you know what? I don't know. Did I? Yeah, there we go. Okay, so it goes red. I couldn't remember if I made it go red. So we've had contact on it, and then we turn it off again. So that's important because we'll need to learn about contact or use contact for our game. So there's our rectangle. We said that it's static, so that's why it's not moving. But when we dot contact, we receive which object contacted it. And if that object is the circle, then we're changing the color to red, and we're setting a timeout. If we contact a lot of it, we might... Anyway, this is just a nice fail-safe way of keeping it so that it will, after 1 second from the last contact, it will turn back to gray. Okay, so that is the net, like an air hockey net or a hockey net, whatever. Here's a tower, like we might have in Angry Birds. And the tower is kind of interesting because we're going to do something similar as well, where it's, those are, I can't pick them up. So I didn't make them draggable, which means I only can shoot like that. And there I've just shot them all about. Oh, but this one would normally be on the ground. So I think what we've done on this is made a system. We figured you want a system to find out, are they all on the ground yet? Which means we're expecting at this point to have gravity. So let's readjust that. And there we are. Oh, and we'll shoot. And there they are, kind of as they fall. You can see when they hit the ground, they go red. And I don't know if there was something when they all hit the ground, but they all haven't hit the ground yet. That brings me to another point. The physics has a walls around it, or borders, we call them, or walls. But we're also calling our little wall around our pink thing walls, so perhaps we'll call these borders. And you can remove the borders, and you can also set up physics to follow the ball. So we could shoot the ball and have the ball, have the ball go off the screen and then the whole physics world follows if we set the physics world to scroll. So that's in here. There's a parameter called scroll. We set scroll true, and then on the circle we would say dot follow. Follow, and that allowed us to do the Angry Birds where we shoot farther than we can see. We've done golf games where we shoot farther. We've done side scrollers, etc., and they use this technique right there and putting in the scroll there. But we're not going to look at that. And so anyway, let's see. That was the tower. But for our tower, we use a technique where we were tiling a bunch of rectangles. So this is a tile. We're saying what we're going to tile. And we make sure that what we're tiling has the registration point in the center. We say how many columns, how many rows, and the spacing in the horizontal and the spacing in the vertical. We then position that whole tile, and that gave us... I'm just looking for our example. There she be. That gave us this tile right here. And then what we want to do is add physics to it. But we want to add physics to each of the things, not just add physics to the whole tile. If we added physics to the whole tile, we could do that, but then the whole tile is like a single box. So what we're doing is we're looping through the tile and each time getting a block. Then, this is an important fact, or important issue, we have to add it to the stage. So physics objects need to be in a container. It's at 0, 0, and a scale of 1. Or we could just add them to the stage, which is basically a container at 0, 0, and a scale of 1. Okay, so the tile itself, this tile, is itself a container that holds all these things, but it is not at 0, 0. 0, 0 is up here. So your physics will not work properly if you try to add physics to things that were not in a container at 0, 0, and also not scaled. All right, so what we're just doing is transferring these things to the stage, then we're adding physics to them. And we're also adding a contact to see if it's hitting the bottom. So did the object it hit, does it have a side or bottom? So the object it hits might be a boundary, type boundary, and boundary has a side of top, right, left, or bottom. And so here we are asking if it's at the bottom, and we haven't already set it to red, then set it to red. Oh, there is a pane for winning. Oh, I should have paid more attention. We could have gotten a pane. Let's do that. We're going to use a pane in our game. So here we go. Let's see if we can... I got to do better than that. Let's see if we can knock these down. Now, I'm cheating a little bit. You see what I'm doing? We win. I'm just using the ball to hit them. And that's actually something we're going to have to worry about as well when we make our game. But there we go. We won. Yay. When we make our game, we don't want to just take the ball and knock things. So what we're going to do is we're going to say, don't turn the color to red, basically. Don't turn the color to red. If, or maybe in our case, we're keeping them static, so we can't even move them at all if the mouse is down. So if the mouse is down, and as soon as we let the mouse up, then yes, you go ahead. So we'll see how that works. But there's a tower. I can tell you're ready to start on our game. Here we can just find out, are we in a certain area? So in this case, we're making a yellow circle. We're adding physics, but we're saying that it's a sensor. And what that means is nothing will interact with it, but the contact still works. So if the contact is hitting the ball, or if our yellow circle is hitting the other circle, the ball, then we're going to change the area to be red. And once it ends contact, we're going to change the area to be back to yellow. And note that our area is yellow, but it's got its alpha 0.5. Okay, so let's see how this works. Basically, as the ball goes... Okay, well, let's take off the gravity. Right there. 0 gravity, and try this again. make it a little bit easier. So now as I shoot, there it goes red, but note that the ball can pass through it and possibly stay in contact. Okay, so that is another way that you could keep score of something, etc. That's a little bit different than bouncing off. All right, good. And finally, we have different types of shapes. So the physics can be added to circle, rectangle, triangle, blob, and squiggle, as well as things like picks and sprites. And sometimes you have a pick that's a picture of a soccer ball, but a pick is square or rectangular. So when you add physics, just tell it, please act like a circle. And then your rectangular picture or sprite of a ball will act like a circle. So that's very cool. And you can also shrink the margin bigger or smaller as well on that if you need to. Blobs and squiggles can be made at this place. It's called paths, and then you take the code. So this is what a blob looks like, for instance. Well, that's okay. And we didn't set it to be draggable, but we could knock it around. Anyway, that's an unusual blob in that it's pretty pointy. So let's see a blob that is usually a little less pointy, but you can see that they can make weird shapes like diamonds or whatever. So here's more of a curved kind of blob, and that looks like this. I haven't got it to be draggable, but there is a problem with this blob, and that is it. I don't know if you can tell from. No, you can't tell. It seems good. Did we fix it up? Points. Yeah, we've added a bunch of points. So if we don't make it, if we make it interactive true, so we took away the interactive, then you can see the points, and you see how it's got those points. What's happening is the physics is really just added between the points. But if we didn't add extra points with this add points right here, just drop this down. I want to undo this eventually. If we didn't add extra points, the blob started off looking like this. So that's a nice, simple blob right there. But you'll see that the physics is broken because it pushes nicely on a point, but in between the points is just a straight line, and that's why you see what's happening there. The physics thinks it's just acting there. Also, we don't want an interactive things like that, like it's fighting. I'm pulling the blob, but the physics is putting it back there. So the physics just draws a straight line between there, and it's basically acting like that. So you would want to add more points, and that smoothens it. Okay, so that's working with blobs. What else do we have in there? Oh, interactive false. Yeah, and so make sure you turn the interactive false. You can also get the blob from a picture, and there's a link. So it will outline a transparent PNG that has a transparent background, that is. It will outline that for you, and then it will make a blob around that and add physics, and all that's pretty amazing. That was just added not too long ago. So check that link out. And then there's joints as well. So the last thing that's that we're showing you here in this basics physics page, because there's other ones as well. There's things like buoyancy. We didn't see the spinning, but there's this thing called category bits and mass bits. Those make certain physics objects interact with other certain physics objects, so you don't always have to interact with everything. But anyway, here's a joint, and let's see what that looks like now. Oh, it's not in this one. It is right here. No, I didn't make it draggable. So we want everything to be draggable. Beep, 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 beep. Then remember to set that back again. And that was .drag, just sets everything draggable there. And now we can pick that up. Okay, so we've joined those two things together. Like little nunchucks. Wah! And you can apply, like you can anchor, you see how we've joined these two things together. If one of these were static or not dynamic, then this one would turn around it. You could apply forces and you could do things like seesaws and I don't know, stuff like that, pendulums. All right, so down here, we made two physics objects. And again, we located them near one another. You could have done that with a tile as well, might have been easier. But then you would have to transfer them to the stage. And then we joined those two objects at a certain point. That's a point in between the two of them. And a second point is only if we have a different type. So there's distance, weld, and revolute. Only the distance has 2 points. You can join two things, a point on one thing and a point on the other thing, or actually anywhere in the world, but usually it's on the things. In this case, though, we have a revolute joint, which only gets 1 point. And then these are the min and max angles. You don't have to set those. You could have set them to null. And then they spin around as follows. Right. Whee! Okay, there you go. That is the physics primer, getting you all ready. Let's now start in on our game. And I want to see if this is roughly in the same shape as we started there. I think it is. All right, and back to our game then. If you want, though, you're welcome to take a little break, go get a cookie, and come on back, and we'll dig in to activating our game, if you so desire. So what we'll do is we will go through the tutorial and put the code in here, talk about it as we go. So here is the tutorial. That's the preparation. I probably could have stayed where I was. Right, we did a little bit of just exploring with a circle that drags, looking at gravity, showing where the docks are, and those are the docks, by the way. Maybe show you where that is too here. So back on Zim, under docks, right there. If you type in physics, like so, the first one you get to, well, depending on where you are in the docks, it might be different, but anyway, when you're at the top, the first one is physics right there, and this is the main physics one with the gravity, the borders, the scroll, and the frame, which I talked a little bit about. And there's a lot of stuff in here as well. So this is our main physics article. There's some examples. Here are the parameters for the physics. Here are the methods for the physics. So that's where you would do the join and the drag. And there's a few other ones as well. Here are the properties for the physics. There's not too many of those. We don't have to worry about them. But then there's the methods for the objects. So such as add physics, remove physics, impulse and force, your spin, torque, follow, control, which does the keyboard stuff, contact end, take away the contact. Contact end is when it stops contacting, but no contact is no longer check for contact. And then there's this new one called puppet, no puppet, where you can control physics objects using Zim animations or Zim objects. And then properties for those. Okay, so that's all there. And if you hit go again, then it goes specifically to the add physics one. And the add physics one has examples again for the add physics, as well as all of the parameters for your add physics. So have a look through those. Okay. All right, coming back here. There's the physics helper file, and we already went through that to see the different types of controls, the targets, and the shapes. And then back to our game. So here we are. All right, we're actually going to do it. And this right here is the circle that has the slingshot added. So I'm going to copy this stuff right here. Copy. And come back here and say, okay, physics was in there. I think it takes away all this stuff right there. And you see how poorly that copied in? Boo. But you can right click and say format document right there. And now all of that is properly indented and looks good. It does indent this other stuff, which I don't usually indent because I kind of like indent. But there we go. That's back to how I like it. We're setting a global style because, I didn't do that right. So up here, now we're making our game. No, sorry, up here, dual monitor. There were a couple more things to set right here. Okay, so copy these two things. One was the import of the physics, which we actually have there. And the other was what did we do to the frame? So here's the frame. We set it to 1,000 and 1,000. So square, we set it white. That's the color of the stage, and black, which is the outer color. And then we're also importing a Google font called Oxanium. Ooh, nice, huh? And to do that, we say GF underscore before our Google font. So nothing to do with physics. And then we're also setting it so that any text that we're putting in here from now on will be that font with the global style. All right, so we save that up, and let's check her out and see what we've got. I don't think it was that one anymore, but this first one right here. Refresh. Good, and we've got our system started. Okay, we're pulling back a ball. No gravity. Our ball is there. It's just a black ball, and we positioned it. Added the bounciness of 0.6 and the linear of 0.2, so that's will go for a long time. And then we're dragging only the circle because we've got other things we're putting on there, and the only thing we ever want to drag is the circle. And then this stuff was what we went over before to do the slingshot. Okay, so we don't really care too much about all that stuff. That was the slingshot. All right, we're ready for our next step then. And that was back down here, right? Okay. And note the bit about pasting it in and then format the document there. Yeah, that's what we get. Those are other types of forces. And now the walls. So here we're going to make a wall. Right there, grab this stuff. Where we're making a tile of little rectangles, all with their registration centered, 8 by 8, and those are the spacings. And then we're going to center reg so that when we spin it, it will rotate. We're not really spinning it, but when we rotate it, it'll rotate about its center. Okay, because later we're going to rotate it. And so at the moment, that gives us the following: a grid. And so we're going to rotate it. We don't do that just yet, but that will be .rot like that, 45. We're going to play around with the physics of it before we rotate it first. Okay, and that will make sure it rotates about its registration point. There's a thing called a registration point. I'll show you what that looks like. .outline. If we do the outline before the registration, I think we have to put it on the stage. Anyway, tab, not caps lock. And we get the following. So there's what it looked like before we rotated. Now we rotate, and you see how it's rotating around the center? That's good. We want that. But if we didn't center reg it and just centered it, then we would see as follows. There it is centered, and then when we rotated, it would rotate about its top left corner. So that's the difference between registration point in the center and the default registration point for something rectangular is the top left corner. All right, anyway, we want center reg like that, and we don't want to outline. Outline is a snapshot in time, so we outlined before we rotated. Otherwise, it would have kept the outline after we rotated. So there's our tile. We now want to add physics to it, but we don't want to just add physics like this, .add physics, because we would get the following. Actually, still rotated. Not rotating at the moment. Add physics. Beep. And it's not draggable, but it is, we can play around with it by knocking it, I guess. All right, that's not what we want. We want individual physics on all of the little guys inside. So what we're going to do is we say tile.loop, and that loops us through our tile. Each time we'll get a little block like that. Is that what we call them? I think we call them blocks. So that's a Zim loop. Well, it's a Zim loop, but on a container. That's how you could do it. Otherwise, if you wanted a Zim loop 10 times, loop 10 times, call this arrow function. Each time we would get I if we wanted to, like that. That's a Zim loop. Isn't that nice? It's so easy, and you can loop through anything. You can loop through an array, loop through a number of times. You can loop through an HTML collection. You can loop through an object literal. You can loop through a container or a tile, which extends a container. So anyway, there we are. Each time we get a block, so we would say block dot add physics. Physics, I can spell it. There we go. And now each block will have its physics added. Oopsies, broken. And it's like, okay, well, almost it tried. Like, what happened there? Remember that we don't add physics to something that is a container that's not at 0, 0. So it just tried to put that at 0, 0, and it's not in the right place. So basically what we want to do is take the block and go dot add to the stage, capital S. I'm going to get my fingers going here. Dot add physics. So that adds it to the stage. But watch what happens. This is an unusual situation here. What happened? I'm crying. Why did these ones not get added? That's because we didn't loop backwards. So every time we add it to the stage, it messes up the index number, and the next one will get skipped in a sense. So every other one is being missed. And certain ones worked, and other ones didn't even get a try. So that's not a Zim thing. That's looping. That's if you have an array and you're pulling things out of the array as you're looping, you got to loop backwards through the array to make sure that you pull everything out of the array. So it's even just raw JavaScript issue. So anyway, Zim makes it easy. That's looping backwards. True for loop backwards. Okay, and now you will see boom, boom, boom. Rah! They're all good. But we don't really want this to happen. What we want is a ball to bounce off it and have the thing disappear. But you can see that we're kind of in the, if we wanted to shoot it off a wall. And we're trying to push them, and we might want to adjust. Density is one issue you could put. Like you can make it have, these things have lower densities, and then when you hit them, the circle will knock them more. Or you can make the circle have a bigger density. Also things like the linear damping on them as well could be changed. How easily they rotate is rotational damping. So if you want them to not really rotate, you can do that. Actually, there is a setting to remove the angular velocity completely, but you can look that up. Okay, so hope you guys are doing well there. What's next? Let's follow our steps. I kind of just started coding again, didn't I? So there we are with the information about looping backwards. And there's what happens. Good. And now what are we going to do? Oh yeah, we're going to dispose if we contact. Well, let's code that together. It's not too much. So inside here, along with the add physics, we are making those first of all false so that they don't move, and then we say dot contact. So when these things contact something, the something they contact is this object right here that gets passed into this arrow function. So now we can determine what the object is. We have to be careful. We don't, well, I guess since they're static, nothing else is going to hit these but the ball. Yeah. Well, if they weren't static, they could hit each other, and we don't want them to disappear if they hit each other. But since they're static, they're not really going to hit each other anyway. The only thing that's going to hit it is the ball, unless we had other physics things there. But anyway, we may as well do a little conditional. If obj is double equal to, what do we call our ball? Circle? Yeah. Okay, so if the object is the circle that we're hitting, then we get to do something. We can say object.dispose, and that means get rid of it. And when we dispose it, it's not a physics thing, this is a Zim thing, but when we dispose something in Zim, it checks to make sure that it's got physics and it removes the physics. We could just remove physics, at which point it wouldn't act anymore in the physics world. Do you want to see what this looks like? But then it would still show up. I'm not sure what this is going to look like. Oh, constant error. Circle.impulse is not a function. Oh, I removed the object. Okay, and I don't want to remove the physics. Yeah, okay, I get it. I want to remove the block. Block. Dot remove physics. So what had happened is I removed the physics, and then I was trying to do... That's interesting. They're all static, but note that I hit the ones, I'm hitting these ones, and then what happens? They're gone from physics, so how will I be able to tell? Yeah, they are gone from physics. If I let go, so you see how it's tricky to show you, because if I've got that, it's going, as I do this, it's taking away the physics. As I do that, it's hitting certain ones and bouncing back. Anyway, whatever. Certain ones in there have their physics removed there. But we don't really want to do that. We want to get rid of them completely. So that is dispose. And that looks like this. It's a failed example, huh? So now as we hit them, they're being disposed. And even if I hit them by picking them up and disposing. So that's what was happening before. They're disposed. But if I do this... it hits certain ones, but obviously if they were disposed, it wouldn't, or sorry, if they had no physics, it wouldn't seem like they're hitting. So they'd all look like they were there, but the ball would pass through them. Anyway, we don't want to be able to pick up the ball and delete them like that, do we? That would be cheating. But we noticed that, or we didn't notice it, but we tell it later in the tutorial here. So why don't we leave it for later? So now we're going to try the 45 degrees thing. So we're trying now to add the physics to these things as 45 degree. But already we've got a pretty cool looking game. You know, I mean, that's, hey, let's try and get rid of all these things. It's like an icebreaker or whatever that thing is. But obviously we don't want to cheat by doing that. But anyway, we've got a game already where we're removing things. And look at our code. That's kind of the code. This thing right here is the same. That is the elastic stuff. So if we just said drag circles, it took all this elastic stuff away. Bing. So there's our code. Physics. We have a circle. We're going to drag the circle. We made a tile. We're going to dispose when we hit the tile. Okay, so if I save that, we've got a circle that's erasing things in sort of like this bouncy physics way. Or if we want, we could throw it at it and try and erase things like that. We're pretty close to a game already, huh? Just with this code right here. Okay, so anyway, this other one was all the stuff for our elastic right there. And then we have our tile. Okay, let's see what's next. So we're angling this. So now as we angle it, we're going to say dot rot 45 like we had before. But if we just leave it like that, something a little peculiar happens. And it's like, okay, well, it's close. But what happens is as we add to the stage, as we add the block to the stage, what is the rotation of that block? The block is inside the tile. The rotation inside the tile's coordinate system is still 0. All we did was rotate the whole container, but inside the container, the rotation is still 0. So when we add it to the stage, it keeps that rotation of 0, and all of the blocks have a rotation of 0. They're positioned nicely, but their rotation didn't rotate. So what we want to do is just rotate them 45. Each one, go on, each one of you rotate 45. And then we get what was expected there. Okay, and good. Now we have a diamond. And the diamond looks pretty cool. I like the the look of it. It's a bit more futuristic or different than just having a normal grid. It's nice. Huh? So what we're going to do now is get a little circle that shows up in the middle, and that's what we're trying to free from our diamond walls. Whoa, black diamond walls. Okay, so to do that, we're going to put the circle in the center. So const, I think we call this one, what do we call it? We're missing it. Step 6, add the pink circle to the middle and remove the blocks. We got no pink circle there. Okay, well that's good. I happen to be in edit mode. I can just add the pink circle right here. Const, what we're going to call it. If the block hit test center, I think we just called it center. So this is the center is equal to a new circle. And we want to know how big that was. I think it was 30. And it was pink. And we'll dot center that. The circles are already a registration point in the center. So there we go. I think that is our code that we want. And then we were going to find out if it hits, we're going to dispose it. So yeah, I'll code that with you here live. So const center is equal to a new circle. It was, I believe, 30 and pink. And dot centered on the stage. All right, so if we want, we've now rotated that thing and we've added it to the stage, but we won't even bother doing this if we're hitting the center circle. So if block dot hit test circle correct. So that checks to see if this circle right here, therefore we better do the center first. So if the circle of center is hitting the rect of the block, then we want to block dot dispose. Else we can say add the block to the stage and set the contact. So okay, so this will make those go away if we're hitting the circle. That's a Zim hit test. And when we refresh here, this circle is hitting these blocks. And now we can still play the game, and we're trying to free that circle. Yay! All right, and yay. Let me just do a double check. We have the simple physics example. So this is all the code right here, and it's 30 and pink. Oh, we should add physics to it too. That's good. We took a look there. Actually, let me change it here first. Yeah, we want to make sure that we have physics for later, so that we can bounce off it and win the game. All right. So that is good. And here, where were we? There. This is physics. And there's the circle. Add physics. Oh, no. Where's the circle? This is red. Oh, this is the wrong one. Physics. I want the other physics. Physics final. Simple physics. Simple physics? No. Did we close it? Oh, there it is, right back here. Physics tutorial. Okay, and add physics. Good. All right, I think we're good. We won't notice that until a later step, but we do want to add physics to that little circle in the middle. Got it so far? Okay, let's come on back here and see, replace the loop. Now we've got that in the center. Great. And what does this do? Step 7, test if our black circle hits the pink circle. So that's hard to test because we got to get rid of all those outside walls. So an easy way would be to reduce the number of outside things there. Why didn't I put that there? So to test more easily, let's make the walls 4 by 4 replace the circle code with this. Right, okay, so the circle code needs this extra little bit here, but no. Copy all of that there. So I didn't say how to change our grid, which is right up above, isn't it? At the moment it is. Where's the grid in this one? That's our new circle. There it is right there. We just want to change these numbers, but our tile loop is in there still too. Okay, where's our tile loop is here. Go up and change the grid to 4x4. Hopefully people can figure out how to change the grid. Maybe a little later I'll put that code in and actually point out the 4x4 change. And then when we hit the circle though, that was on our circle. So we're putting that on center, or are we putting it on the circle that we're dragging? Let's have a look. So that's our circle that is black and 40. So not on the center circle, but on this circle right here. Just be careful. So we now have two circles. And this indenting is dreadful. I don't know if it'll let me format this. There we go. So we have two circles, but I was saying just be careful. If we actually went in and added, all we're adding really is this contact right here. If we add the contact to it, note that we had the semicolon in there. So we have to get rid of this semicolon so we can then join on the contact there. Okay, so we went up to our circle and we added contact that said if the object that the circle is contacting is the center object, that's our pink circle in the center, probably should have chosen a better name for that, then we win. So we're going to dispose our center. I thought this was a really cool way to handle this. We get rid of the center and we turn our own circle pink. Isn't that cool? Because it's like we're playing this game of reflection and all of a sudden the thing we're trying to save becomes us. It's sort of like after reflection, we are whole, or we're saved. So it's sort of like this metaphysical theme in behind it all, self-reflection. All right, let's see if it works, shall we? And since we changed this, where was it, here, to 4x4, we should be able to break in a little bit easier. I'm kind of looking for our break-in. It's here underneath. Okay, so ready? Let's see if we can break in. Bum, bum, bum. And I wonder we could still just break in this way. Okay, ready? Whoa, cool! So as soon as we hit the ball, it disappears and turns this one to be pink. So that's pretty cool. Okay, let's see what we've got next then. That's the core of the game. And we do mention that this would have been 10 times the code in Box2D, which doesn't even have a visual way of showing, but we've got a debug mode, and you can set physics.debug true or something like that, debug round brackets, maybe it's a method. Can't remember, see the docs on that. And then you can see what Box2D is doing in behind, and some of the linkages, like the mouse linkage there, you can see little lines join. It's kind of cool to look at. But anyway, Box2D takes 10 lines to make a box. It's like, hey, they lived up to their name. Zim, it's new rectangle.addPhysics. It's one line, .addPhysics. And basically that is doing 10 lines in the background of fixtures and all this other crap. So that's good. And then in general, Zim is 3 times less code. So did I say that right? In other frameworks, it is 3 times more code. Yeah, so we have this right here on Zim. So you can check out this, first of all. That talks about why things are less. But also, down below here are these stats, and this is only partial stats. So and this is like from 5 years ago, and it's just, we've done double the comparisons since then, and it's same average. So basically we're coming in at much less code than all these other things. Yay! All right, so some extras now in step 8. You notice that we can drag the ball and hit the other things, so let's fix that. So what we're going to do is we're going to track when the mouse is down. And in this little variable right here. And then when we go to hit, so let's copy these guys and throw them in, and we'll find out where we go to hit. We'll just say, hey, if it's down, you can't hit. So I'll put these down here at the end. So whenever we stage mouse down, we have a mouse down. Whenever we stage mouse up, we have a mouse up. I was looking to see if we had a frame property that says if the mouse is down or not. I don't think we do. We have a left mouse down, which probably would do it. So there's f.left mouse or something like that will be true or false. But with pointers, probably with pointers, it would also, on mobile and stuff like that, I think it would still work. But this is easy enough to do. So now we don't want to dispose the block right here. That is, wait a minute, which one is this? Else block add to state. No, this is the disposing it. If it hits a circle, where are we doing our dispose of the blocks? Contact, that's us contacting the center. We want to contact. Kind of mixed up as to where it is. Maybe it's in here. Contact. Yeah. If object is the circle, then block. No, this is it right here. Yeah. So in here we say if down, return. So don't even check if we're currently have the mouse down, and that should stop us from getting rid of all that code easily. Yeah, see, that's, now I can't just knock on that. So we're left knocking on it for real. All right, that was pretty simple to solve, huh? Okay, and let's see what's next then. We also should add some effects like particle emitters when the wall is disposed. So there's our emitter right there. I'll copy our emitter code, stick it in somewhere. I don't think the order particularly matters so much here. Format document. It might, and if so, then we might have to move it about. But there's our emitter. And what we're emitting, so this is a new emitter, we're emitting a rectangle that's 30 by 30 and has any of those colors and is rotated 45. Initially we didn't rotate it 45, and then we noticed, oh, all our parts aren't at 45 degrees, so we just rotated them 45. We're starting paused, otherwise it would emit if we put it on the stage. And then we're also making it not as forceful. Those particles are so small that with the default force, which I can't remember if it's 10 or something, they just kind of shoot out pretty fast. If you want to see what the emitter looks like, then you can do something like this, dot center, and oops, and just have a look at your emitter, see what that's like. It's behind the circle, so if we made it the emitter after, maybe we should, let's make the emitter, as I was saying, it doesn't quite matter where it goes, but you see we made the emitter before our center circle, so I guess we'll make it down here. And that's what our particle emitter looks like. But you see that's kind of like shooting out quite a lot for a circle hitting it. So we reduced the force a little bit, and that looks like this. It's just kind of a bit smaller as it hits, and that's too many and going all the time. So we want to start it paused, so now it won't be shown. We don't need to center it because we're going to, right here where we dispose the block, before we dispose the block, because we need the block's position, we can say emitter.loc at the block, and loc expects an x and a y, so x comma y, and then what container and what layer. But if you loc it at something that has an x and y property, then it will just locate it there. So emitter.loc at the block, and then dot spurt, and we say how many times, 10. So now every time we break a block, It makes a little spurt. Isn't that cute? Oh. So easy, huh? Bing, bing. And we would also play a sound at that, which if we had a sound would be sound dot play. To make a sound, it's new odd, but we don't want, and of whatever your MP3 is or whatever, but we don't want to say new odd dot play every time we hit. So we would store the odd in a variable and then that variable dot play. Then you got volume and stuff like that as well. All right, so what's next? Step 10, at the end, we want a pane to pop up saying that we won. All right, so let's do that then. How do we know we've won? We hit the circle, so that was back up here, wasn't it? Yeah, so here, new pane. And what do we want to say? You win! Whoa! Or you are free. There we go. And then we can dot show that pane. And show the pane, ladies and gentlemen. And that looks like this. Oh, we have to break in. And darn, we can't cheat this time, so I'm kind of cheating because the actual game is to reflect off certain walls. Oh, okay, I'm ready. Come on. Yeah! You are free. Like that. Note that it puts the background to be a little dark like that. So we did some adjustments to our pane. We also wanted to see the transition to pink better and let them look at it. So we didn't pop up the pane right away. Instead, we wait a bit and pop up the pane. So the actual code that we did was right here, a timeout, and then we showed the pane, and we also changed the background alpha. So I'll just copy that, stick that in here. It's kind of annoying, isn't it? Timeout tab. Okay, so we wait 1 second, and then we're making a new pane with congrats, you are free. But one of those pane parameters is the backdrop color, and we just jumped right to it with by setting a style. Or we could have said something like content is congrats, you're free. It's been a little bit easier to look at, comma, backdrop color. That. Okay, so new pane, the content is congrats, the backdrop color is that. And that also would have worked, but instead we had made the pane with just the simple message there, normal parameters, and then got lazy and styled the backdrop color, which also works too. Okay, so we see a pane, and that will work as well. I don't have to test it again. And what else in it looks like that? Oh, we also moved it, though. I thought we moved. No, we didn't, because it was timed, and the circle goes off and goes somewhere else, and so we just left it in the center. You could add sounds and images, and we have other examples on the HTML5 tutorials page, which was back out here under tutorials. There's the HTML5 ones, or go to the front and get to the game ones. Remember these? So these guys have, like that guy's got scoreboards. So this is called crisscross right here. Let's open it up with a full view. So, and in this one, there's a timer. So we brought in the game module for timer. I think the physics module comes with the game module built in. And then there's the score. So every time I made a mistake. Every time I press these things, I don't want this to hit the wall, but this is that sort of the farther, if I hit the red, it goes faster. All sorts of things happening. If I hit the inside, it goes slower, and I don't want to hit those walls, because hitting the edges takes away from it very well. All right, so that's got sounds. It's got a local storage to remember your last score. We have a leaderboard too, and I think there was an example of a leaderboard on one That's in the game module. And this is a timer, and that's a scorer. Okay, so that's a more complete physics game right here, so you can check all that stuff out. And there's other ones in here too that have a scoreboard. Does this one have a scoreboard? Yeah, so there's a scoreboard on it, so that shows you how to do the scoreboard. And then this is a tile-based game to spot the orb that doesn't change. Oh, there's another one. Do you see it? That's it. Okay, fine. Now those are the two. Now we have to find three. Anyway, that's one of those games, and you can check all that stuff out. Good. So where were we now? Back on here, huh? Challenge. So one of the things about this game is that it's not terribly challenging, really. So we could keep score. So making it so that there's a time limit, or how fast can you release it. That helps it be challenging. Or count how many times you have used your circle. That's sort of just like a bit frustrating. 1, 2. Oh, I missed. Anyway, that's all right. That does the challenging. But check this out: a twist. Okay, so a better way to challenge users with a twist. Something that makes it different than the basic mechanics of just trying to get in there. And the twist in this case is we are supposed to bounce it off of a wall first before. So instead of just hitting it like that, we're supposed to bounce it off a wall and then hit it. And when we did that initially, it was, well, we should bring back the full tile here. Full tile. It was 8 by 8, and that's another thing. We could do levels too, where it's easy to start and then gets harder each time. And there's some levels examples in that other one. What I found is I would sit here and I would kind of chomp away at one side like that, and just chomping away at one side was, it's okay, but it wasn't terribly challenging either. I just sort of sit and carefully do it. So what I did was made the walls change. So basically, you have 10 seconds to use this wall, then it moves to this wall, then it moves to this wall. And that way, you sort of have to plan out your situation a little bit more. You have to be aware of when the wall's going to change, it fades out, and a few other things like that increase the fun aspect of it. Okay, so that's what we have decided to do for the twist. So record a bounce off the border. All right, let's take a look and see how that was done. It's right here. So when we contact this is on the circle, okay? And so if down, return, there it is. So if the object's type is a border, then set the bounce to true. So let's do that. This is our circle bouncing, which is up here. Something looks different. Where'd our down go? Didn't we do a test on down? Oh yeah, because we don't have that yet. So that's right in here. There's a few other things in here that we don't have. A few other things that we don't have in here. The down. Right. Okay. So we have to add that too. So that's where did it all go? Center.dispose right here. So if down, then leave. Because we're not going to want to, we don't want them to do the following. We don't want them to pick up the ball and hit the border like that and then shoot. So it's hard for me right now. So I could have picked up the ball, hit the border, and then shoot. I don't want that to happen. I want to only count a border hit when I've released the ball. So don't even bother checking if I'm on down. And then if the object that I'm hitting is of type border, then set the bounce to true. So that's going to work on any border. And what we're going to do later is change it. We're in the extras here, and I'm aware that we've got you here for a long time. We're at an hour and a half or so. Also, I'm doing something fun. Sorry to interrupt. Well, it's not going to the beach is fun. I am doing the following. Captures. What am I looking for? HTML5. Yeah, there we go. I am doing the following. This guy right here. Tomorrow. So today is Saturday, and I'm preparing for this game jam. And the workshop that I'm taking the attendees through will be the physics stuff that I've just been showing them. So I kind of got to watch my voice a little bit. It's feeling a bit hoarse, and I've got an all-day game jam tomorrow to do the keynote speak and the workshop, and then we're doing the game jam. So I think I'm going to kind of keep it a little bit quicker here and show you, just sort of talk about what we did in the end. Instead of a general border, we would say if the object that we're hitting's side is equal to a variable called side. And then basically we make this rectangle that goes from one side to another, and it stores this variable side. So for instance, if I say right in here, R-I-G-H-T, now the bounce will only be true if I've hit the correct side there. That being the, why don't we call it the top? So if we hit the top, then it will be the correct one. And then down below, where we're doing this guy, right here, is this it? Yeah, there's our emitter. So if down return, but we also, if the down is return, that's fine. But we also want to say, and we're not combining these on purpose. Otherwise, we could have said if down return, if down, or not bounce return. But anyway, if bounce, so if we've got the bounce, then we're going to do this stuff. So we've got something else that we're going to do too that means that these need to be in different conditionals. All right, so that's fine. That's going to return us out no matter what if we've got a mouse down. So if we're hitting things as we're holding the ball, we don't even want to check what's going on. But otherwise, if bounce, we're going to block it. So what would this do now? Got it? If we hit from the side, it doesn't. So if I hit from the side, it doesn't do that. But if I hit from the top, get back up to the top. If I hit from the top, oh, didn't do it either. Okay, well, what happened? Did I save it? If bounce, so down wasn't that? Bounce should have spurted my blocks. So I must have done something wrong up here. Maybe it's not side. Let's just have a look and see. Perhaps it's a different property that I was looking for. After play testing, we found it was too easy to keep bouncing off the top. So what we're going to do is rotate the border. Here's the border rotation. And that's all the border rotation stuff. Where was our little test, though? Those are the sides. It was called, I think it is side. And where did we put in the side here? That's that stuff. If object.side is equal to side. Yeah, obj.side set bounce to true. So I thought we did something like that already. If obj.side equals top. And here we're hard coding one of them. So those are the right names, aren't they? They don't have capital letters. Yeah, those are the right names. And if that's true, then we should be setting bounce to true. Oh, when did we set bounce to false? So we also have to set bounce to false anytime we pick it up right here. So that would be bounce equals false. But obviously, since we didn't even set it to false at all, that should have bounced once and been true for ever since then. There we go. Let's do a zog in here to see if we're bouncing properly. Bounce. Zog. Oh, I know what it is. Do you see what it is? The OBJ is what we're the circle's content. Yes, okay, that's right. No, sorry, that's not it. OBJ is going to be one of the sides. Good. So zog obj.side, and we'll zog this in red so it shows up in our console in red, and see what that's like. F12, and oh, I got bad errors already. Bounce is not defined. Bounce. I didn't set up a variable. I didn't set up a bounce variable. So that's here. Let bounce equal false. Okay, so we were just getting an error on that. Yeah, let's try her again. So now I bounce off the top, and it worked. Okay, bounce off the side, and it doesn't work. So here I am bouncing off the sides, and when it hits a block, there is no left, top, right, or there is no side, so it's giving me undefined. But if I bounce off the top, and it breaks. If I bounce off the sides, bottom, left, this one's undefined, that's undefined. So now I'm bouncing off, you see I'm bouncing off the bricks. But it's working if I bounce off the top. Yay! Okay, so all that was working, I just hadn't declared a variable. And we had that the movement of the bar, so there's a bunch of bar code, and the bar code really, it had the word reflection in it. It doesn't really have anything to do with physics, so I'm fine doing it. But basically, as we rotate it around, we're getting the side from the rotations happening inside a ticker or timeout, or sorry, interval, wherever the interval is. There it is. And this code, it gives an indent of one. Is it one column or is it two columns? I can tell. I think it's just one column indent. It's like, come on, guys, give me a little bit more indent than that. But anyway, there's our interval, and we're rotating each time, and we get an interval object, and that interval object has a count, like how many times we've done it, and we're using the percentage for to handle the rotation and the looping through that array, basically. That's the modulus for. Right, but that's pretty well normal JavaScript in there. It's just putting a rectangle that's rotating around the side. The cool thing is we added our logo or our title to the rectangle as well. And that's good. That gets this rectangle that rotates around, and you have to bounce off the side with the rectangle. The last step, or almost the last step, aside from the instructions maybe, is what do we do if we bounced off the wrong one? And that was kind of exciting. So that was, when we bounce off the wrong one, we put in that else. So let's just put in that else and give it a go. So that was where, that's the circle contacting. I think it was down below. And this one, yeah. If the bounce is good, then we get rid of it. Else, and this was the else. Nice. Else, we're going to set the block color to clear, add a border to it, and take off the contact. So if there's no contact anymore on the block, that's this thing right here. If there's no contact, we're never going to dispose that block again. And you could put a cooldown on it, like a time that it can't be, so watch. Here I've hit a side, and what just happened? I don't think it's working. It is not working. Bounce, set the block to clear, save it up. Oh, I didn't save my document. Saved. Now, if we bounce, we're good. That's off the top. But if we bounce off the side, we're bad. Oh, I must have hit the top during that bounce structure. So if it bounces and then hits the top eventually. So anyway, those things I can't break into again. So see that? So I can't get past those. They'll never leave. And anytime that I'm not bouncing off the top, that must hit the top. But anytime I'm not bouncing off the top, I get that. So I can only at the moment break through bouncing off the top. Can't break through bouncing off the sides or the bottom. I love that one. Huh? Completely goes around the whole dangle. So that was the penalty. Excuse me. The penalty, where it inserts those. And that's kind of neat, because then you're left, as you're trying to bounce off a side up here, you have to get it in a smaller area. You have to sort of slip through. Maybe I could slip through there, maybe not. And there you go. Final instructions show up at the bottom there. They animate in, so we animate them in right there. Over time, slowly kind of animates in. Then when we mouse down on the circle, we wait just a little bit and animate them out, and then dispose it. You know, you have to dispose it. Nobody will notice, but it's probably good. And this on the mouse down, that right there means only run that mouse down once. So it won't try and do it again at another time. So basically we just dispose the instructions once we picked up the circle. We initially just had it animate in and animate back out and just left it at that. But it's better to let them see it a little bit longer, and as soon as they start playing, then we animate them out. Something else I was going to say about it, you just got to watch it, because what was happening is we get all this stuff shows up at the beginning, and then the bar animates in. I don't want to animate the instructions in at the same time as I animate the bar in, because then you got two animations going at the same time. So we animate this in, we slowly animate this in, or if we wanted to, we probably could have just put a wait on. You see how we've got waits for animating off? We could have put a wait in here to wait for this animation a little bit, but we just slowed down that. So it's basically this only takes a second to animate in. This one's taking 5 seconds, so you see this one first, then you see this one. And same with picking up the ball. I don't want to pick up the ball, that's not the ball for real, I don't want to pick up the ball and have this immediately animate out, because I'm in the act of picking up the ball. I want to concentrate on I almost don't even want to see that go away. I want to concentrate on the fact that I've got a string here. So I just wait a little bit and then animate the ball, animate the instructions out. Okay. Anyway, I've been making interactive media for a long time. I'm Dr. Abstract, this fellow here. You're always welcome to find me, Dr. Abstract, down at the bottom as well. Actually, does that go anywhere? It goes to, yeah, about Zim. I probably go to Dr. Abstract. I have the Dr. Abstract site, drabstract.com. And there I am. That's what I look like. And you can read more about me and have me do any talks or whatever. There's also a 3D site here, which is quite wonderful, that has all these stories.
Dr. Abstract.
And there's about Dr. Abstract.
Dan Zen was the name.
Okay, and information about coding, if you like coding.
Dr. Abstract.
And these all have stories, and you can go to the next one and see.
The motto of Zim, Code in 5 Minutes with
puzzles.
Zim, is a fun way to see the diversity and ease of coding with Zim.
These things and
press the pick to go to the video series.
Okay, all the best. This has been an HTML5 coding tutorial. I think you've got everything you need. The actual code is there in the editor as well if you need it, and you can find that code all on the HTML5 page right here. So this goes to the editor, and you can find the code for that, start working on it, try out all the other ones as well. It's been a pleasure to have you here for this Make HTML5 Games with Physics. All the best. Have a great day or night. Cheers.